On the first day of July, the sky above the Atacama Desert in Chile seemed no different from any other clear winter morning. The sun had risen over the jagged peaks of the Andes, spilling its golden light across the world's driest desert. At a robotic observatory perched high above the barren plains, the ATLAS telescope, a machine designed to watch the heavens relentlessly, scanning for asteroids and other near-Earth objects, clicked and whirred, sweeping across the infinite black tapestry of space. But that morning, ATLAS found something no astronomer had expected, something extraordinary, a tiny glimmer of light, moving against the backdrop of distant stars, blinked onto its sensors. At first it was dismissed. Countless dots of light crossed telescopic fields every night, distant stars, galaxies, cosmic noise, and occasionally satellites from Earth itself. But this particular point of light was different. It moved too fast, too purposefully, to be a star, even a typical asteroid. When the data was transmitted to NASA's Jet Propulsion Laboratory in Pasadena, the initial excitement was tempered by disbelief. Preliminary calculations showed that the object was traveling at a staggering velocity of or roughly 36 miles per second. For context, even the fastest known objects in the solar system, like Voyager 1, humanity's furthest reaching spacecraft, travel at only a fraction of that speed. The object's trajectory indicated it was not gravitationally bound to the Sun, meaning it had entered our solar system from somewhere far beyond the familiar orbit of Pluto. Within hours, astronomers across the globe were alerted. The scientific community, which rarely experiences such immediate, collective astonishment, began poring over the data. Observatories in Europe, North America, and Asia trained their instruments on the newcomer. Each new observation confirmed the initial finding. This was not just another asteroid or comet. This was something interstellar. The object was quickly designated 3I Atlas. Following the nomenclature for interstellar objects, the I signifying its origin outside our solar system, this designation also hinted at its remarkable rarity. Before 3I Atlas, humanity had recorded only 2 such visitors, Oumuamua, detected in 2017, and 2 Borisovs, spotted in 2019. Both had been anomalies, objects that challenged conventional understanding of celestial mechanics. But 3I Atlas, scientists realized almost immediately, was unlike anything seen before. While Oumuamua had been elongated, roughly the size of a football field, and Borisov resembled a typical comet from the outer solar system, 3I Atlas dwarfed them both. Initial estimates suggested a diameter between 6 and 9 miles, comparable to Manhattan Island. Its immense size, coupled with its velocity, immediately elevated it from a mere scientific curiosity to a subject of profound significance. As astronomers worked feverishly to model its trajectory, one detail became increasingly perplexing. 3I Atlas's path through the solar system seemed almost calculated. Unlike typical interstellar objects, which follow erratic, random routes dictated by gravitational forces, this object appeared to navigate a series of planetary flybys with precision. Its trajectory would take it past Mars, then Earth, then Venus, before ultimately exiting the solar system again, interacting closely with multiple planets along the way. The probability of such a precise alignment occurring by chance was estimated to be less than 0.005%. Among the many scientists studying 3I Atlas, Harvard astrophysicist Avi Loeb was particularly vocal. Loeb had previously argued that Oumuamua might have been an artificial probe sent by an alien civilization, citing its unusual acceleration and lack of a cometary tail as evidence. Observing 3I Atlas now, Loeb found himself confronting a far more compelling case for extraterrestrial technology. In his estimation, the object's immense size, high velocity, and seemingly deliberate trajectory were consistent with a spacecraft of advanced design, perhaps sent intentionally to observe Earth and other planets in our solar system. Yet, as intriguing as these hypotheses were, they were met with skepticism by most of the astronomical community. Observers noted faint but observable traces of gas and dust surrounding 3I Atlas, features characteristic of a comet. The object's brightness suggested the presence of reflective ice, and its trajectory, while unusual, could still be explained by gravitational interactions, unnatural celestial mechanics. Still, the question remained, was this just another interstellar comet or something far more extraordinary? The tension within the scientific community mirrored the enormity of the discovery. Here was an object traveling at 36 miles per second, hundreds of times larger than new MUA, approaching the inner planets of our solar system, and yet its true nature remained unknown. Telescopes and instruments across the globe, strained to gather as much data as possible, became a potential clue in the unraveling of a cosmic mystery that could reshape humanity's understanding of the universe. For the public, the news was simultaneously thrilling and terrifying. Headlines appeared worldwide: giant alien object headed toward Earth. Scientists stunned by interstellar visitor. Could this be the first proof of extraterrestrial technology? Speculation ran rampant, blending fact with fear. Social media erupted with theories, some grounded in science, others purely imaginative. Intelligent object entering the solar system captured the collective imagination of a species long accustomed to thinking of Earth as isolated in the cosmos. As July progressed, 3I Atlas approached the orbit of Mars, reducing the distance between itself and the inner planets of our solar system. Scientists calculated that its closest approach to Earth would occur on December 19, still a staggering 167 million miles away, but close enough for detailed observation. During this window, telescopes would study its reflective surface, measure its trajectory with extreme precision, and attempt to detect any anomalies that could hint. The discovery of 3I Atlas reignited one of humanity's oldest and most profound questions: are we truly alone in the universe? Even the most cautious astronomers could not escape the implication. If MUA had been a probe sent hundreds or thousands of years before to observe distant star systems, could 3I Atlas be its successor or its mothership? Was it simply a natural object, or had an advanced civilization from far across the galaxy decided to monitor our planet, carefully observing from interstellar distances? At that moment in the dry, wind-swept expanse of Chile, as the ATLAS telescope continued its silent vigil, humanity faced a revelation: the universe had sent a visitor, and this time we might be ready to watch, to record, and perhaps to understand. But what exactly 3I Atlas was? An interstellar comet, a technological probe, or something even stranger remained a question whose answer could redefine everything we thought we knew about our place in the cosmos. The initial observations of 3I Atlas sent ripples through the astrophysics community, awakening long-dormant debates about the nature of interstellar visitors. At NASA's Jet Propulsion Laboratory, teams of orbital dynamicists huddled around computer terminals, analyzing the object's velocity vectors and trajectory precision. For each second, 3I Atlas was traversing more than 36 miles, a distance that would place New York City on the opposite side of the United States in under an hour. At such speeds, even the minute's measurement error could drastically alter predicted paths, complicating efforts to understand its potential interactions with planets and moons. Dr. Maya Chen, a young orbital physicist at JPL, worked tirelessly alongside her colleagues to refine models of 3I Atlas's approach. "It's like nothing we've ever seen before," she muttered, eyes glued to her multi-screen console. On one monitor, a 3-dimensional simulation of the solar system rotated slowly, with 3i Atlas depicted as a tiny, fast-moving speck streaking past Mars. Colored trails represented gravitational influence and predict trajectories. The precision of the simulation, even a slight miscalculation could result in misrepresenting the object's closest approach to Earth by tens of thousands of miles. While the JPL team focused on trajectory, spectroscopists across the world analyzed the light reflected from 3i Atlas. Using sophisticated spectrographs mounted on large ground-based telescopes, they attempted to decode the object's composition by splitting its reflected light into its component wavelengths. Early readings suggested a mixture of silicate rock and icy compounds, reminiscent of comets, that originate from the Oort cloud at the edge of our solar system. Yet subtle anomalies in the spectral lines hinted at something unusual, higher than expected reflectivity in certain wavelengths, and a near absence of dust trails typically associated with comets of comparable size. Dr. Rafe and her team debated the implications. "It's reflecting light in ways that defy normal expectations for a comet of this size," she noted. "It's as if the surface has been engineered to maximize reflectivity, or perhaps it's coated in a material we don't recognize." Meanwhile, in Cambridge, Massachusetts, the media frenzy surrounding 3i Atlas intensified. News outlets ran sensational headlines: "Massive alien object enters, SOF being watched," and "Giant interstellar visitor harbinger comet." Social media amplified speculation, blending science with fantasy. Amateur astronomers posted blurry photographs of faint streaks across the night sky, claiming to have seen 3i Atlas with backyard telescopes. In parallel, suggesting everything from alien mining operations to secret government missions to intercept the object. Despite the sensationalism, the scientific community remained cautious. Any claims of artificial needed rigorous proof. Yet the speed, trajectory, and unusual reflective properties kept at least a portion of the astrophysicals community awake at night, pondering the possibility that humanity was witnessing an intelligent design from across the galaxy. Back at JPL, teams developed models to predict 3i Atlas' gravitational interactions with the inner planets. Unlike ordinary comets, which experience subtle trajectory changes from planetary perturbations, this object's approach appeared almost orchestrated. Simulations suggested that, if current velocity and trajectory held, 3i Atlas would pass within 0.5 AU of Earth, where 1 AU or astronomical unit is roughly 93 million miles. While this distance posed no threat of collision, it would bring the object close enough for extremely high resolution observation using both Earth-based telescopes and space observatories, such as the Hubble Space Telescope. Hubble, with its unparalleled imaging capabilities, became the focus of an intense observational campaign. Astronomers planned sequences of high-resolution photographs, spectroscopy scans, and infrared imaging to detect surface composition, rotation, and any potential outgassing activity. Each data point was critical: minute details in motion, brightness variation, or spectral signature could provide clues to whether 3i Atlas was a natural object or something more extraordinary. Meanwhile, theorists began running advanced simulations to explore hypothetical scenarios. Some speculated that 3i Atlas could be an interstellar probe, sent centuries or millennia ago by an alien civilization. Others suggested a natural origin: perhaps it was a fragment of a shattered exoplanet or a rogue planet ejected from another star system, hurtling across the void until it entered our solar system. Each scenario carried profound implications. A natural origin would provide rare insights into planetary formation processes elsewhere in the galaxy. An artificial origin would force humanity to confront the reality of intelligent life far beyond the reaches of Earth. The debates were not confined to the academic realm. Governments quietly took notice. Classified briefings were held in the United States, Europe, and Asia. Defense agencies examined radar possibilities, planetary protection protocols, and contingency plans, if nothing else, to ensure that such a massive object could not pose an unexpected threat to satellites or space infrastructure. While public statements emphasized safety and curiosity, the discovery of 3I Atlas sparked unprecedented levels of international coordination. As summer waned, 3I Atlas crossed the orbit of Mars, a silent turretin passing through the inner solar system. Its approach allowed astronomers to refine models of its rotation and shape. Using light curves variations in brightness as the object spun, scientists concluded that 3I Atlas was not a perfect sphere, likely elongated or irregularly shaped. Rotation periods were estimated to be roughly 7.8 hours. Although minute inconsistency suggested possible non-minus uniform surface density, or even internal cavities, Dr. Chen considered the implications carefully. A comet this size rotating this quickly shouldn't maintain structural integrity, she said. It's either incredibly strong, made of some unknown material, or it's hollow or something else entirely. By mid-August, the first images of 3I Atlas began circulating. Despite being just a series of faint, grayish smudges and telescope images, the sheer scale of the object became apparent. A city-sized mass, possibly even continental in scale, was streaking silently through the void. Its enormity and the precision of its path fueled renewed speculation. If it were an alien construct, its creators would have to possess knowledge and technology far beyond humanity's reach. And yet, there were subtler hints that left even the most cautious observers uneasy. The light reflected from 3I Atlas showed periodic fluctuations that did not correspond solely to rotation or shape. Some researchers posited this might indicate active surface manipulation, like reflective panels or engineered oscillations, while others suggested naturally occurring phenomena such as ice jets or magnetic interactions. Regardless, the observations fed a growing fascination. 3I Atlas was not merely passing through, it seemed almost aware of its surroundings, interacting with the solar system in a manner too precise to be entirely random. By September, anticipation had reached fever pitch. Observatories around the world planned coordinated campaigns for the closest approach in December, deploying arrays of instruments to capture every possible data point. Advanced radar studies aimed to probe internal composition, infrared telescopes sought subtle heat signatures, and radio telescoped for emissions that might indicate intelligent activity. For the first time in history, humanity had months, not years, to study an interstellar object on its way to the inner solar system before it vanished forever back into the cosmic void. As the world watched and waited, one realization became impossible to ignore. 3I Atlas was a messenger from the galaxy, arriving silently yet deliberately, forcing Earth to reckon with the vast unknown that lay beyond the familiar night sky. On July 1st, the robotic telescopes of the ATLAS survey in Chile picked up an anomaly. A small glowing dot moved with extraordinary speed against the backdrop of distant stars. At first, it seemed like any other interstellar object, but within hours, astronomers realized it was unlike anything previously recorded. Its trajectory suggested deliberate precision rather than randomness. It was heading toward the inner planets, and potentially toward Earth itself. The object was quickly designated 3I Atlas, marking it as the third interstellar visitor known to humanity. Unlike its predecessors, Oumuamua and Borisov, This object was massive. Preliminary calculations estimated a diameter between 6 and 9 miles. This was comparable to the length of Manhattan Island. Astronomers immediately began running detailed simulations to predict its path. Every calculation confirmed the initial observation this was no ordinary celestial body. Its velocity exceeded 130,000 miles per hour. That meant it would cross the distance from New York to Los Angeles in just over a minute. For comparison, Voyager 1 travels at approximately 38,000 miles per hour. The sheer scale of 3I Atlas made it both ominous, inspiring, and terrifying. If an object of this magnitude were to collide with Earth, the consequences would be catastrophic, but its speed suggested it would not impact directly. Instead, it would perform a series of close planetary flybys. Its path would bring it within 17.5 million miles of Mars. It would pass Earth at a distance of 167 million miles. It would then approach Venus at about 60 million miles. Finally, it would skim past Jupiter on its return trajectory in 2026 at only 33 million miles. Astronomers were stunned. The probability of an interstellar object navigating such precise gravitational corridors was less than 0.005%. In other words, it was nearly impossible for this alignment to occur naturally. The trajectory suggested intentional design. Professor Avi Loeb of Harvard University was among the first to voice this interpretation. He proposed that 3I Atlas might be a technological probe from an extraterrestrial civilization. If true, this would mark humanity's first confirmed encounter with alien engineering. Such a possibility, however, raised profound questions. Why would its path avoid Earth as the closest approach? Loeb hypothesized that the object's creators might be deliberately avoiding direct contact. Perhaps they intended to study us without revealing themselves. The timing of its closest approach to Earth would occur on the opposite side of the Sun. From our perspective, the object would be perfectly illuminated, yet the Sun would prevent us from observing it directly. It was a cosmic game of hide minus and minus seed. The implications of such intent were staggering. Humanity might be under observation without knowing it, and the technology required to travel interstellar distances implied immense sophistication. The propulsion systems alone would surpass anything humanity had ever created. Perhaps even weaponized potential existed, although there was no evidence of hostility. The world's space agencies began intensive monitoring campaigns. Telescopes from Chile to Hawaii, from Europe to Asia, were rained on the object. Every photon, every minor shift in trajectory was recorded and analyzed. Even the faintest emission could provide clues about its composition and origin. Some hypothesized that 3I Atlas carried instrumentation sensors or communication arrays. Others suggested it might be completely autonomous, programmed to survey stellar systems. The sheer speed and mass of the object posed extraordinary challenges. No spacecraft humanity could currently build would reach it in time to intercept. Yet the concept of a chase mission began to form in the minds of leading scientists. Advanced calculations suggested that a probe could, theoretically, leverage gravitational assists. A complex sequence involving Venus, Earth, and Jupiter could impart sufficient velocity. Chemical propulsion systems could fine-tune the trajectory. Solar orbit maneuvers might provide additional acceleration, drawing energy from the Sun's immense gravity. Even laser propulsion was considered, using high-powered Earth-based lasers to nudge the probe. But these plans were still largely theoretical. They required precision beyond current engineering capabilities. Still, the idea of intercepting an interstellar object captured imaginations worldwide. Scientific conferences were convened to debate strategies. Data was shared openly in unprecedented collaboration between nations. Astronomers, physicists, engineers, and mathematicians joined forces. Simultaneously, the public became captivated by the story. News outlets, social media, and forums buzzed with speculation and concern. Could this be humanity's first contact with extraterrestrial intelligence, or merely an exceptionally large comet ejected from another star system? Each theory carried weight, Each possibility demanded rigorous evaluation. Meanwhile, the object approached Mars orbit. Images taken from telescopes revealed a faint but distinct glow. Dust and gas emissions were minimal but detectable. Some scientists argued that even this light activity suggested a natural cometary origin. Others maintained that the lack of a visible tail relative to its size supported the technological hypothesis. Simulations indicated that 3I Atlas had likely crossed the Oort cloud roughly 8,000 years ago. At that time, Earth was in the late Neolithic period. Civilizations were beginning to establish settlements. Agriculture was spreading, and writing systems were emerging. Loeb speculated that this period of human development might have drawn the attention of distant observers. Perhaps they waited millennia for conditions to become favorable for observation, or perhaps they had been monitoring the solar system for much longer, unseen and unnoticed. In either case, the presence of 3I Atlas represented a rare opportunity to study interstellar physics and potentially contact. The first visible images of 3I Atlas revealed a surface unlike any asteroid previously catalogued. Its color was dark but slightly metallic, reflecting faint sunlight in irregular patterns. There were no prominent craters, suggesting either a smooth surface or constant self-repair. Spectroscopy revealed traces of rare elements, some of which were uncommon in the inner solar system. These included isotopes of iridium, osmium, and tantalum, arranged in ratios that puzzled chemists. The composition seemed engineered rather than naturally occurring. In addition to metal traces, there were microscopic signs of what might be organic molecules. Carbon chains and amino acid minus-like structures were detected, though in extremely low concentrations. The possibility of contamination was considered but quickly ruled out. No natural comet or asteroid exhibited these same patterns in previous surveys. The size, speed, and trajectory combined with the unusual composition caused intense debate. Could 3I Atlas be a probe designed to study planetary systems discreetly? Or was it an artifact of a natural process we had yet to understand? As weeks passed, astronomers monitored subtle variations in brightness. These fluctuations hinted at rotation, or perhaps internal mechanisms. Calculations suggested the object rotated every 7.3 hours. If the rotation was artificially controlled, it implied remarkable engineering capabilities. Even minor adjustments to spin would require advanced propulsion or stabilization systems. The world's leading space agencies began drafting plans for hypothetical interaction. Though no physical interception was feasible, signals could potentially be sent. Radio telescopes tuned to multiple wavelengths attempted communication. Low-power pulses were transmitted in various sequences, seeking any response. So far, no deliberate signal was received. Some researchers argued that even a lack of response was a form of communication. Perhaps the object was observing silently, gathering data before revealing itself. Meanwhile, simulations projected its path across the inner solar system. On October 17, 2025, 3I Atlas would make its closest approach to Earth's orbital path. Though still millions of miles away, the gravitational influence on other bodies could be measured. Minor perturbations in the asteroid belt were observed, consistent with its predicted trajectory. This allowed scientists to refine models with unprecedented accuracy. Predictions suggested a minor lensing effect on background stars. Gravitational lensing could be used to estimate mass and density. Early data indicated a mass approximately 10 billion metric tons. Its density was surprisingly high, rivaling iron-rich asteroids. Such density supported the hypothesis that the object was not a loose collection of rock and ice. Some speculated that it could contain hollow chambers or internal structures. Others imagined propulsion engines embedded deep within, invisible to telescopic observation. As data accumulated, the public's fascination grew. Documentaries, articles, and online discussions debated the object's nature. Science fiction enthusiasts speculated wildly about alien civilizations, secret messages, and hidden technology. Religious groups interpreted 3I Atlas in symbolic terms, some calling it a sign of impending change. International organizations began discussing global strategies for potential contact. Emergency protocols were drafted, though no immediate threat existed. Still, the unprecedented nature of the event demanded preparation. Satellite networks were ready to capture high-resolution images during the closest approach. Space agencies coordinated schedules to maximize observation windows. Amateur astronomers also contributed valuable observations. Crowdsourcing data allowed near-continuous monitoring of its movements. Even minor shifts were tracked with extraordinary precision. By early September, 3I Atlas had crossed the asteroid belt. Images showed subtle but unmistakable anomalies in its reflection patterns. Shadows moved in ways inconsistent with simple rotation. This suggested either variable surface features or dynamic internal mechanisms. Scientists debated the implications. Could the object be scanning the solar system in real time? Or were the observed fluctuations merely optical illusions caused by distance and light scattering? Further spectroscopy analysis revealed faint emissions in the radio spectrum. Though weak, these signals were consistent and rhythmic. Some hypothesized a self-contained energy source, perhaps nuclear or otherwise unknown. Others suggested it might be an automated data relay recording observations for its creators. Regardless, the presence of any emission reinforced the hypothesis of artificial design. By mid-September, the object had entered Earth's orbital plane. Its velocity relative to Earth was nearly 120,000 miles per hour. At this speed, even a minor deviation could drastically alter its path. Scientists continued to refine trajectory models hourly. Simultaneously, theoretical physicists explored the possibility of its propulsion system. Could it be using solar sails, gravitational assists, or an entirely unknown method of faster than light acceleration? Models incorporating known physics could not fully explain the object's precision. This led to speculation about exotic technologies. Perhaps it utilized a time-matter propulsion or manipulation of gravitational fields. Even concepts like controlled micro-wormholes were entertained, though highly speculative. Every hypothesis required rigorous scrutiny and peer-reviewed validation. The interdisciplinary collaboration became unprecedented in human history. Astrophysicists worked alongside engineers, chemists, computer scientists, and even philosophers. The philosophical implications were profound. Humanity faced evidence of a civilization capable of interstellar travel. The sheer technological gap was staggering, yet there was no direct threat. This realization sparked a mixture of awe, excitement, and existential anxiety. For many, it was a reminder of humanity's infancy in cosmic terms. The object's closest approach would occur on October 17th. Still months away, preparations continued. Even space telescopes, like the Hubble and James Webb, were scheduled to capture critical data. Observations focused on surface details, emissions trajectory, and potential anomalies. Scientists also debated the possibility of using neutrino detectors or gravitational wave sensors. Perhaps subtle disturbances in space-time could reveal hidden aspects of the object. The combination of techniques would provide the most comprehensive data ever collected from an interstellar visitor. On July 1st, a faint but unmistakable glimmer appeared on the screens of observatories worldwide. Astronomers in Chile scanning the depths of space with the robotic telescope of the ATLAS project noticed something unusual. A point of light, moving with astonishing speed and precision, had entered the inner reaches of our solar system. At first glance, it appeared as nothing more than another comet or asteroid, yet its velocity, trajectory, and apparent size defied conventional explanation. This was the object that would later be named 3I Atlas. Its origins were clearly interstellar, and its approach toward our solar system had already set the scientific community on edge. Unlike MUA, which passed fleetingly and vanished almost as quickly as it was discovered, 3I Atlas promised a prolonged engagement, a chance to study an object that might not merely be natural. Its size was staggering. Estimates suggested a diameter between 6 and 9 miles, comparable to a small city, dwarfing Oumuamua's 377 foot length. The scale alone suggested the possibility of something more than a random fragment of rock or ice. Could this be an artificial construct? If so, what intelligence had sent it? Avi Loeb, a professor of astronomy at Harvard, immediately drew comparisons to his earlier theories regarding Oumuamua. He pointed out the extraordinary precision of the object's trajectory, calculated to pass near for planets in the solar system: Mars, Earth, Venus and Jupiter. The statistical probability of such an alignment occurring naturally was infinitesimal, less than 0.005%. Loeb suggested that the path was deliberate, as if the object's course had been meticulously plotted to gather maximum observational data on the planets, perhaps even Earth. Yet even at its closest approach to Earth, 3I Atlas would remain at 167 million miles, almost twice the distance from the Earth to the Sun. This raised profound questions. If the purpose of this interstellar visitor was reconnaissance, why not come closer? Loeb proposed a fascinating hypothesis. The object may deliberately avoid direct proximity to intelligent life, studying us without revealing itself, its path orchestrated so the Sun would obscure our view at the moment of closest approach. Its speed was equally extraordinary. Traveling at 36 miles per second, 3I Atlas could cross the distance between New York and Los Angeles in just over a minute. The forces necessary to accelerate an object of its size to such velocity implied technologies far beyond current human capabilities. If artificial, the propulsion systems could involve unknown methods, possibly harnessing solar radiation pressure, advanced ion drives, or some form of energy conversion that remains theoretical to us. The object's journey had begun thousands of years ago. Calculations suggested it crossed the outer boundary of the solar system, the hypothetical Oort cloud, approximately 8,000 years ago. At that time, humanity was only beginning to establish civilizations, invent writing, and settle in large communities. Could this timing be mere coincidence, or had the object's creators observed the rise of intelligence on Earth from afar, marking our civilization for study? As the days passed, observatories around the world tracked the object, noting its trajectory, brightness, and faint emissions. Despite its enormous size, 3I Atlas emitted little visible light beyond reflection from its surface, and no radio signals were detected. Its composition remained a mystery, though the reflectivity suggested a rocky or metallic surface rather than icy materials typical of comets. Scientists considered multiple scenarios. Some argued it was a naturally occurring interstellar object, ejected from another star system, a fragment of a planet or a rogue comet. Others, inspired by Oumuamua, entertained the possibility of artificial origin, a reconnaissance probe, or even a mothership sent ahead or following a previous exploratory craft. The timeline of its approach through the solar system provided opportunities and constraints. On October 2, 3I Atlas would pass 17.5 million miles from Mars, a distance close enough to study gravitational interactions, but not so close as to impact the planet. Subsequently, its flyby of Earth on December 19 would place it at 167 million miles visible, but largely untouchable for direct observation. Venus would see a closer approach at 60 million miles, and on its return path in 2026, the object would pass Jupiter at 33 million miles. Each flyby was a cosmic dance, perfectly aligned in a way that suggested either an extraordinary coincidence or deliberate design. The pattern defied conventional physics for random celestial objects. Loeb and his colleagues believed it highly unlikely for planetary close passes to occur naturally without intentional orchestration. Observing the object required precision instrumentation. Large telescopes, such as those of ATLAS, Pan-STARRS, and the Hubble Space Telescope, were employed to capture high-resolution images and spectral data. The data gathered would help determine albedo, surface composition, and potential anomalies in trajectory or emissions. As scientists debated the object's nature, the dark forest hypothesis loomed in the background. This concept, derived from the Fermi paradox, suggested that intelligent civilizations may intentionally remain hidden, avoiding detection by potential cosmic predators. If 3I Atlas were artificial, could it be humanity's first contact with an advanced extraterrestrial intelligence, cautious and observant but not hostile? Or might it be a threat, its enormous size and velocity carrying the potential for catastrophic consequences if miscalculated? The ongoing study of 3I Atlas represented a convergence of multiple scientific disciplines: astrophysics, planetary science, orbital mechanics, and even speculative exobiology. Teams of scientists, engineers, and mission planners considered the feasibility of sending intercept probes, designing instruments capable of surviving extreme speeds and interstellar conditions. Unlike UMUA, which passed quickly for a detailed mission, 3I Atlas's prolonged approach allowed for months of observation. Every calculation, every image, and every spectral reading contributed to humanity's understanding of interstellar objects and the potential for encountering artificial structures from beyond our solar system. To the public, the story was gripping: a mysterious interstellar giant, possibly a spacecraft, approaching our planetary neighborhood. Media outlets and science communicators emphasized both the wonder and the unknowns, creating a mix of excitement and apprehension. The arrival of 3I Atlas was more than just a celestial event. It was a test of human ingenuity, observation, and preparedness for an interstellar mystery. The questions remained unanswered. What exactly was 3I Atlas? Was it natural or artificial? Was its trajectory intentional or a cosmic coincidence? And if intelligent, were its creators benign observers, neutral explorers, or something entirely beyond our understanding? As the object moved closer to Mars's orbit, all eyes in the astronomical community were trained on it. Each new image, each measurement, each calculation provided incremental insights, but also amplified the uncertainty. Humanity was witnessing in real time a rare visitor from the depths of space, and the implications of its presence stretched far beyond mere academic curiosity. In essence, 3I Atlas had become a mirror, reflecting not only the vastness and mysteries of the cosmos, but also humanity's ambition, imagination, and readiness or lack thereof for interstellar contact. The closer 3I Atlas drew to the inner solar system, the more detailed its features became under scrutiny. Telescopes captured its elongated form, a strange, almost spindle-like body stretching for miles, with subtle variations in surface reflectivity hinting at a complex structure. Deep grooves ran along its length, suggesting either erosion from cosmic travel or perhaps engineered design. Spectroscopy analysis revealed faint traces of metals not commonly found on Earth: titanium, nickel, and an unusual alloy resembling materials used in advanced aerospace engineering appeared on its surface. Yet no trace of atmosphere or volatile outgassing common in comets could be detected. This reinforced the idea that 3I Atlas was more than a mere cosmic rock. It might be a durable, intentionally designed object. Scientists debated endlessly over the implications. If it were artificial, the purpose remained a profound mystery. Could it be a probe sent to catalog planetary systems in search of intelligent life? Or perhaps a data collection vessel, monitoring the rise and fall of civilizations across galaxies? Some speculated that it could even be a remnant of a long-extinct alien race traveling silently through space, oblivious to the worlds it passed. The trajectory continued to astonish. Every planetary flyby, every gravitational deflection seemed perfectly calculated, as though the object were navigating a predetermined map. It was as if some intelligence had charted its course thousands of years ago, anticipating the positions of planets, the alignment of stars, and even the evolution of life on Earth. The discovery of 3I Atlas sparked debates within governments and scientific institutions. Advisory councils convened emergency sessions to assess the risks. Was there a possibility of collision? Would its passage through the solar system trigger gravitational perturbations significant enough to alter orbital paths of planets or asteroids? Simulations demonstrated that while the object posed no immediate threat to Earth, its immense mass and velocity could subtly affect smaller bodies, nudging comets or asteroids onto slightly different courses. Meanwhile, astronomers and engineers considered the technological challenge of reaching the object. At 36 miles per second, even a spacecraft traveling at a fraction of that speed would require decades to intercept. Yet the potential payoff, a close-up study of an interstellar object, possibly artificial, was unprecedented. Plans were drafted for micro-probes that could be accelerated using solar sails or gravitational assist from planets, hoping to rendezvous with 3I Atlas for detailed imaging and sampling. Public fascination grew alongside scientific analysis. News outlets reported on the cosmic visitor, emphasizing both its mystery and its grandeur. Social media was flooded with renderings, simulations, and speculative theories. Artists imagined enormous spacecraft, alien civilizations, and technological wonders beyond human comprehension. Children dreamed of meeting beings from another star, while scientists quietly debated the ethics of potential contact. Amid the excitement, a small team at the European Space Agency proposed an audacious experiment. Using advanced radar and laser systems, they attempted to measure the spin and rotation of 3I Atlas. Surprisingly, the object exhibited a slow, deliberate rotation, unlike natural interstellar debris, which tends to tumble erratically after ejection from a star system. The rotation axis remained remarkably stable, suggesting active stabilization or an inherent structural design that maintained equilibrium over millennia of travel. NASA's Jet Propulsion Laboratory joined the effort, calculating gravitational interactions with the Sun and planets to refine its orbital model. Simulations confirmed previous observations the object's path was too precise to be a natural accident. This reinforced Loeb's hypothesis that 3I Atlas might be an interstellar probe, intentionally avoiding collision but maximizing observational data from the planets it encountered. Speculation about its origin ran wild. Some theorists suggested a distant star system, perhaps several thousand light-years away, had launched the object. Others proposed it originated from a civilization that had long since vanished, leaving only this silent witness to traverse the stars. The distances involved were staggering. The light we saw from the object had traveled millions of years, passing through the void before reaching our instruments. In effect, humanity was looking at a relic of another civilization, frozen in space minus time, carrying information or perhaps a message through the galaxy. As the object approached Mars, interest intensified. Observatories in the southern hemisphere provided continuous coverage, revealing more details of its surface. Crater-like depressions dotted the surface, some appearing natural, others suspiciously geometric. Ridges, channels, and grooves hinted at either erosion processes unknown to science or, intriguingly, the deliberate placement of structural features. The pace of discovery accelerated. Spectrometers detected faint emissions in the infrared spectrum, hinting at potential energy sources beneath the surface. The possibility arose that 3I Atlas could harbor machinery or stored energy. Though no direct evidence of life or artificial activity was detected, scientists cautioned against premature conclusions, but acknowledged the unusual signatures demanded further investigation. The cultural impact was profound. Books, films, and documentaries sprang up overnight, attempting to capture the imagination of the public. Universities hosted conferences to discuss the scientific, philosophical, and ethical implications of an interstellar visitor. For the first time in history, humanity collectively turned its attention outward, not merely in search of knowledge, but with the acute awareness that the universe might not be silent. Meanwhile, debates erupted over the potential for contact. Some argued for restraint, advocating observation and caution. Others suggested sending a signal, attempting communication with a visitor that had already traversed light-years to reach our neighborhood. Loeb and colleagues remained cautious, emphasizing that any action should be guided by scientific rigor rather than speculation or excitement. By December, the object was nearing its closest approach to Earth, still far beyond direct reach, but close enough for precise measurements. Radio telescopes scanned continuously for emissions, yet none were detected beyond the faint cosmic background noise. Its apparent silence was unsettling, reinforcing the idea that it might be deliberately avoiding detection, observing us without revealing itself. Scientists marveled at the precision engineering evident in its orbit. Gravitational slingshots around planets were calculated with millimeter accuracy, implying Falcon-walled of planetary positions thousands of years in advance. The implications were staggering. If 3I Atlas were artificial, it demonstrated a level of sophistication far beyond current human understanding. It was a testament to the ingenuity and technological prowess of whoever or whatever had sent it. Amidst the excitement and uncertainty, philosophical questions arose. If intelligent life had reached this level of technological mastery, what were their intentions? Were they explorers like humanity, curious and cautious? Or were they observers, assessing our development without interference? The possibilities ranged from benign curiosity to strategic surveillance, yet none could be confirmed. As the solar system's days passed, the narrative surrounding 3I Atlas evolved. It was no longer merely a celestial object to be catalogued. It had become a symbol of humanity's place in the cosmos, a reflection of our curiosity, our ingenuity, and our yearning to understand the unknown. The final weeks before the closest approach were marked by an unprecedented global effort. Teams of astronomers, physicists, engineers, and mission planners coordinated across continents. Data sharing was continuous, simulations updated in real-time, and every discovery analyzed collaborative. The scientific community had never mobilized on such a scale for a single object, and the collective anticipation was palpable. Then, on December 19, 3I Atlas reached its closest point to Earth. Though still millions of miles away, the observations were the most detailed humanity had ever captured of an interstellar visitor. Its surface revealed subtle variations, faint glimmers, and patterns that resisted natural explanation. The data would take years to fully analyze, yet even preliminary findings hinted at the extraordinary. 3I Atlas was unlike any known asteroid, comet, or natural interstellar object. For the first time in human history, the universe had sent a visitor of unmistakable presence, one that demanded attention. The implications of its passage would ripple through science, philosophy, and culture for decades. And while 3I Atlas continued its journey beyond the inner planets, leaving Earth behind, the questions it raised lingered. Who sent it? Why? And what does its presence mean for humanity's future among the stars? As the sun set on that historic day, telescopes across the world remained trained on the fading speck of light. The world had witnessed the arrival of 3I Atlas, and in doing so, humanity glimpsed the vast, mysterious, and possibly intelligent universe beyond its cradle. And thus, the stage was set for the next chapter in humanity's encounter with the interstellar unknown, a journey of discovery, challenge, and revelation that had only just begun. Even as 3I Atlas drifted beyond the inner planets, its passage left an indelible mark on human observation. Astronomers and engineers began to scan deeper into space, wondering whether the object had been alone or if it was part of a larger network. Among the cacophony of cosmic radiation, a subtle anomaly appeared, faint pulses in a narrow band of the electromagnetic spectrum, irregular but unmistakable. Dr. Eleanor Cortez, a radio astronomer at the Atacama Large Millimeter Array, was the first to notice the pattern. At first, she dismissed it as interference from terrestrial satellites, but repeated observations confirmed its extraterrestrial origin. The pulses exhibited characteristics that defied natural explanation. They were too structured, too consistent, and yet subtly variable, as if encoding information. Global attention shifted once again. News outlets speculated about alien communication, while scientists debated the implications in hushed conferences. Could these signals be a message from 3i Atlas itself, or perhaps a companion object, a distant relay or probe monitoring our response to the visitor? Theories multiplied, each more ambitious than the last. Teams of cryptographers and linguists were recruited to decode the signals. They applied every known method: Fourier transforms, prime number analysis, statistical pattern recognition, and even machine learning algorithms trained on human languages. Each attempt revealed tantalizing hints, yet no complete deciphering could be achieved. It was as if the pulses were designed to reveal themselves gradually, challenging observers to rise to the level of their creators. Meanwhile, the global scientific community debated the protocol for responding. Some advocated silence, fearing that any reply could attract unwanted attention. Others argued that humanity had a responsibility to acknowledge the presence of intelligence and attempt communication. International committees convened emergency sessions, drafting tentative frameworks for ethical contact, balancing caution against curiosity. As months passed, the signals grew more complex. Subtle variations suggested modulation, perhaps indicating numerical systems or visual patterns. Some sequences mirrored the prime number patterns Carl Sagan had once suggested might be recognized by alien civilizations. Others hinted at geometric arrangements, reminiscent of fractals or crystalline structures, suggesting that the sender possessed advanced mathematical understanding. In parallel, theoretical physicists speculated on the medium through which the signals traveled. While radio waves were the most plausible carrier, certain anomalies hinted at alternative forms of communication: gravitational waves or neutrino-based messaging technology far beyond human capability. The possibility arose that 3i Atlas, or its creators, had harnessed exotic physics to encode information across light-years. Public fascination intensified. Documentaries chronicled the hunt for meaning in the pulses, highlighting the international collaboration and the ingenuity of those attempting to understand them. Artists imagined the alien mathematics as music or visual art, blending science with creativity in unprecedented ways. Children sent drawings and letters to observatories, expressing hope, fear, and curiosity. Dr. Paz and her colleagues worked tirelessly, cross-referencing the signals with astronomical databases. Patterns occasionally coincided with the rotation of distant stars, suggesting a possible stellar origin or a deliberate timing mechanism, yet no direct correlation could be confirmed. The universe, it seemed, remained deliberately enigmatic. One night, a breakthrough occurred. A graduate student named Rico Tanaka noticed a repeating sequence that mirrored the Fibonacci series. It was subtle, embedded in the timing of pulse intervals rather than frequency or amplitude. Excitement tripled through the team. The presence of a universally recognizable mathematical patterns suggested intent and intelligence. If the sender expected to be understood, Fibonacci was an ideal starting point, a bridge between civilizations separated by light-years and eons. Encouraged, the team developed algorithms to predict subsequent pulses. By modeling expected intervals based on mathematical sequences, they attempted to anticipate the next pattern. Success was partial but promising, revealing that the signal contained layers of information nested like Russian dolls. It was as if the sender anticipated that only persistent, analytical minds would gradually uncover its message. Meanwhile, Loeb and other astrophysicists revisited 3i Atlas' trajectory. They theorized that the signals might correlate with its path, suggesting that the object could have been intentionally placing these pulses along a navigational route. If true, it indicated a level of foresight and design that challenged even the most advanced human engineering. Every observation, every measurement seemed premeditated, pointing towards some goal yet to be revealed. As winter gave way to spring, the signals intensified. New pulses arrived with higher amplitude and richer frequency content, implying either increased power from the source or refined communication methods. The scientific community raced to upgrade instrumentation, expanding bandwidth and improving sensitivity. The world held its breath, waiting for the elusive message to emerge from the cosmic void. In the midst of these discoveries, philosophical debates erupted once more. Was humanity ready for contact with an advanced civilization? Could we even comprehend their technology, motives, or culture? Religious scholars, ethicists, and futurists weighed in, warning against hubris, while acknowledging the transformative potential of such a revelation. Amid the turmoil, researchers remained focused on the data. Patterns continued to emerge: prime numbers, geometric sequences, and subtle references to physical constants, such as pi, the fine minor structure constant. The complexity suggested not random noise but deliberate encoding, a methodical attempt to convey knowledge across interstellar distances. In laboratories across the globe, interdisciplinary teams formed. Mathematicians collaborated with computer scientists, physicists with linguists, and engineers with philosophers. Every discovery sparked new avenues of inquiry, yet the core message remained elusive. The signals were not hostile, but neither were they immediately comprehensible, a challenge designed to test perseverance, intelligence, and creativity. Late one evening, Dr. Cortez stared at the oscillograph, mesmerized by the pulse patterns. Subtle variations suggested a form of binary representation, possibly a sequence of instructions or data packets. It was the closest glimpse yet at the alien mind, encoded in the language of mathematics, physics, and time. The realization dawned: humanity was not merely observing, we were participating in an interstellar dialogue. Each attempt to decode the signals became an act of communication, a response in its own right. The universe, silent for eons, had chosen this moment to engage, challenging humanity to rise to its level of comprehension. As months turned to years, the effort became a defining moment for civilization. New technologies emerged from the attempt to interpret the signals, revolutionizing computing, data analysis, and communications. Societies worldwide were united by a shared purpose to understand the message, to respond appropriately, and to grasp the profound implications of intelligence beyond Earth. And in the quiet hours, as telescopes scanned the night sky and satellites recorded the faint pulses, humanity began to recognize its place in a vast, interconnected cosmos. 3i Atlas had passed, but its legacy remained an invitation to explore, to question, and to imagine civilizations that stretched across the stars. As humanity delved deeper into the signals, subtle patterns emerged that hinted at far-reaching concepts, ideas that challenged conventional physics, mathematics, and even philosophy. Some sequences corresponded to fundamental constants, while others suggested a knowledge of multi-dimensional geometry far beyond human understanding. Researchers began to speculate that the sender was attempting not just communication, but a form of education, a guided introduction to concepts humanity had not yet discovered. Dr. Z and her team experimented with visualizing the signals in three-dimensional form. When plotted as dynamic structures, they revealed intricate, rotating lattices that resembled hyper-complex crystal structures, constantly shifting and unfolding. The patterns were mesmerizing, simultaneously symmetrical and chaotic, revealing layers upon layers of hidden information. These visualizations inspired mathematicians and artists alike, blending the boundaries between science and art. Meanwhile, new teams of biologists and neuroscientists explored whether the pulses could encode more than mathematics, possibly life-related data. Some proposed that the signals contained genetic information, or even blueprints for molecular structures, though no definitive proof was yet available. The mere possibility ignited debates about bioengineering, ethics, and the responsibility of humanity if such knowledge were deciphered. The signals also had temporal properties that defied comprehension. Certain sequences appeared to reference events from billions of years ago: stellar formations, planetary alignments, and even cosmic events that predated Earth's existence. It was as if the sender had captured the history of the universe, encoding it into pulses that traveled across light-years with patient persistence. The temporal aspect suggested not only intelligence but a perspective that spanned eons, one that humanity could barely fathom. International cooperation reached unprecedented levels. The United Nations established the Cosmic Communication Council, coordinating resources, data, and research from space agencies, universities, and private organizations worldwide. Virtual platforms allowed real-time collaboration across continents, with researchers sharing models, code, and hypotheses. For the first time in history, the pursuit of knowledge transcended borders, united by the singular goal of understanding an alien message. As the signals continued to arrive, anomalies in their structure became increasingly apparent. Occasionally, subtle deviations appeared, resembling minor errors or noise, yet careful analysis suggested deliberate insertion, a method to test or guide the observers. It was as though the sender anticipated our methods and subtly nudged humanity toward correct interpretation. The signals were not static, they were interactive, adapting in real time to human understanding. Ethical debates intensified. Could humanity handle such knowledge responsibly? If the signals contained advanced technology, could it be misused? Global discussions weighed the potential benefits against existential risks, with experts warning that a single misstep could have catastrophic consequences. Yet most agreed that ignorance was no longer an option. The signals demanded engagement, not avoidance. In the midst of this effort, an unexpected discovery altered the trajectory of the research. Riko Tanaka, the graduate student who had identified the Fibonacci pattern, noticed that certain sequences aligned with quantum fluctuations in laboratory experiments. This suggested that the signals might not only encode information, but also influence matter at a fundamental level. The implications were staggering. The communication could be an interface with reality itself, a bridge between information and physical phenomena. Government agencies, while initially cautious, began to see potential in this revelation. Advanced laboratories were established to study the interaction between the pulses and quantum systems. Experiments demonstrated that under controlled conditions, the signals could induce minor but reproducible effects in particles and fields. The line between message and technology blurred, hinting at a civilization capable of manipulating the very fabric of space-time. As the scope of discovery expanded, societal impact became undeniable. Education systems adapted curricula to include advanced mathematics, physics, and communication theory inspired by the signals. Artists, writers, and musicians drew inspiration from the alien patterns, creating works that bridged the human imagination with concepts beyond Earth. Public fascination grew, transforming cosmic observation into a cultural phenomenon as pervasive as any global event in human history. Amid this unprecedented progress, philosophical questions loomed. Were we being guided toward a universal understanding, or merely observed as one of many civilizations in the galaxy? Some speculated that the signals were a test, a measure of readiness for interstellar inclusion. Others feared they were a warning, a subtle demonstration of capabilities could be dangerous if misunderstood. Yet the prevailing feeling was one of armed curiosity. The universe had extended an invitation, and humanity was answering. In laboratories and observatories around the globe, collaboration deepened. Machine learning algorithms, informed by human intuition, began to recognize higher order structures in the pulses. Patterns suggested not only mathematical relationships, but also conceptual frameworks, philosophical, scientific, and potentially artistic. Each breakthrough revealed more questions than answers, yet the iterative process propelled human understanding forward at unprecedented speed. Months turned into years, yet the signals remained enigmatic. Despite extensive decoding, the full content was not yet understood. Nevertheless, humanity had changed profoundly, scientifically, culturally, and philosophically. The effort to understand the pulses became a defining chapter in human history, shaping the next generation of thinkers, leaders, and explorers. One night, as doctors reviewed the latest data, A new sequence appeared in elegant arrangements that suggested intentional closure. The pulses aligned in such a way that, for the first time, a coherent framework emerged, hinting at a message designed for comprehension. It was an invitation, perhaps, to join a larger cosmic dialogue or to prepare for encounters yet unseen. The nature of the message remained unclear, but its presence was undeniable. The universe was no longer silent. Humanity had crossed a threshold. The encounter with 3i Atlas had begun as curiosity, evolved into discovery, and now heralded a transformation of consciousness. The signals from the void were more than information. They were a bridge to a broader understanding of existence, a challenge to rise beyond limitations, and a reminder that intelligence, in any form, carries the potential to illuminate the cosmos. And as the night sky glimmered with distant stars, humanity listened, watched, and learned, aware that somewhere beyond the reaches of known space, a silent companion awaited, patient and wise, its message echoing across the void, shaping the destiny of a species on the threshold of the stars. The world had changed. The signals from 3i Atlas had become more than scientific curiosity. They were a force that reshaped civilization. From laboratories to classrooms, through governments to private citizens, everyone was engaged in the process of understanding. For the first time in history, humanity was united not by conflict, but by a common quest to comprehend the cosmos. Dr. Reyes stood on the observation deck of the orbital research station. Below her, Earth's blue surface shimmered with the faint reflection of city lights, while above, the stars stretched into infinity. She thought about how far humanity had come in such a short time. Once the signals had been mere anomalies, curiosities detected by chance. Now they had become a roadmap to knowledge, to discovery, to transformation. Teams of scientists worked tirelessly, analyzing every nuance of the pulses. Some focused on mathematical patterns, seeking hidden constants and ratios. Others explored physical implications, experimenting with quantum interactions, attempting to determine if the signals could be harnessed to manipulate matter or energy. Even psychologists and sociologists joined the effort, studying the human response to the signals and how exposure to such advanced concepts reshaped thought processes and cultural norms. Amid the excitement, caution persisted. Global councils debated the ethical implications of new discoveries. The possibility that the signals could alter reality itself demanded careful oversight. A single misstep could have consequences far beyond anything previously imagined. Yet the human desire to explore and understand was impossible to contain. Risk and curiosity danced together, inseparable in the pursuit of cosmic truth. Riko Tanaka, now a recognized leader in the research community, had developed a method for modeling the signals using high-dimensional matrices. Her algorithms allowed for visualization of multi-layered sequences, revealing connections that were invisible to conventional analysis. Through these models, the team noticed a recurring motif, a structure that resembled a bridge, a pathway leading from one framework of knowledge to another, as though the sender had anticipated humanity's cognitive limitations and created scaffolding for learning. The implications were staggering. The signals were not merely information, they were pedagogy. They guided thought, prompted discovery, and shaped comprehension. Humanity was being taught, nudged toward an understanding that spanned not just physics or mathematics, but a holistic comprehension of the universe's architecture. Meanwhile, the public engagement was extraordinary. Educational programs based on decoded patterns were introduced worldwide. Students were learning advanced mathematics and physics decades ahead of normal curriculum, inspired by real-time cosmic discovery. Artists began incorporating the signals into visual and musical works, creating performances that echoed alien rhythms and structures. Even ordinary citizens felt connected, as though the universe itself had extended a hand and invited them to participate. One evening, Dr. Cortez convened a global conference via holographic transmission. The room, virtual and physical combined, was filled with minds from every continent. Representatives from space agencies, universities, and private research firms presented their findings. It was a convergence of intellects, an unprecedented collaboration that transcended borders, politics, and even disciplines. In the conference, discussions turned to the philosophical. Could humanity ever truly understand the sender? Some argued that the signals represented a form of consciousness beyond human perception, a mind that thought in dimensions and temescals incomprehensible to humans. Others believed the pulses were designed to be understood if approached with patience and the correct methodology. Debate was intense, but consensus emerged. The journey itself was as important as the destination. As research progressed, subtle anomalies in the signals began to appear. Patterns shifted, sometimes almost imperceptibly, as though reacting to the methods used to decode them. It was a feedback loop. Humanity interpreted the signals, and the signals responded, introducing new layers of complexity. This dynamic interactions suggested not only intelligence, but awareness and active engagement with the observers themselves. Global technological advancements accelerated. Quantum computing, once a niche field, became the foundation of new research infrastructure. Laboratories designed to interface directly with the signals were constructed in orbit, beneath oceans, and in remote deserts. The goal was no longer merely understanding, it was creating systems that could adapt and interact with the signals in real time. Despite these advancements, uncertainty lingered. The more humanity understood, the more questions emerged. The signals hinted at phenomena that challenged the very laws of physics as understood on Earth. Non-local interactions, temporal anomalies, and structures that seemed to exist across multiple dimensions simultaneously. Scientists debated whether these effects were practical, theoretical, or even safe to pursue. Amid these debates, a young prodigy named Mina Hassan discovered a connection between the signal sequences and human cognition. Her research suggested that exposure to the signals enhanced abstract reasoning, pattern recognition, and even emotional perception. It was as if the communication was tailored not only to transmit knowledge, but to elevate the consciousness of those who engaged with it. This raised profound ethical and philosophical questions. Were humans being altered in ways they could not fully comprehend? Yet the allure was irresistible. Governments and private organizations invested billions into exploration and experimentation. New instruments were designed to detect subtler features of the pulses, to capture data that could previously not be measured. Every breakthrough revealed layers previously unseen, like peeling back infinite petals of understanding, each more intricate than the last. Dr. Softon reflected on the nature of the endeavor. The universe, she realized, had extended an invitation, not merely to observe, but to participate. It was a challenge, a test, and an education rolled into one, a cosmic curriculum for a species on the verge of its greatest leap. The threshold of understanding lay before humanity, vast and uncharted, promising both revelation and peril. And yet, as the world pursued this unprecedented knowledge, a sense of unity emerged. Nations collaborated, communities learned, and individuals found purpose in the pursuit of comprehension. For the first time, the stars felt accessible, not as distant points of light, but as beacons guiding human thought and endeavor. Humanity had crossed the first threshold, and beyond it, the universe awaited with mysteries yet untold. The first half of Chapter 5 concludes with the recognition that humanity's journey had only begun. The signals were no longer anomalies, they were catalysts. Every decoded sequence, every mathematical insight, every artistic interpretation pushed the species closer to a new epoch. Yet the greatest challenges, the deepest mysteries lay ahead, hidden within the folds of space-time and understanding itself. The world had changed. The signals from 3I Atlas had become more than scientific curiosity. They were a force that reshaped civilization. From laboratories to classrooms, from governments to private citizens, everyone was engaged in the process of understanding. For the first time in history, humanity was united not by conflict, but by a common quest to comprehend the cosmos. Doctor stood on the observation deck of the orbital research station. Below her, Earth's blue surface shimmered with the faint reflection of city lights, while above, the stars stretched into infinity. She thought about how far humanity had come in such a short time. Once the signals had been mere anomalies, curiosities detected by chance. Now, they had become a roadmap to knowledge, to discovery, to transformation. Teams of scientists worked tirelessly, analyzing every nuance of the pulses. Some focused on mathematical patterns, seeking hidden constants and ratios. Others explored physical implications, experimenting with quantum interactions, attempting to determine if the signals could be harnessed to manipulate matter or energy. Even psychologists and sociologists joined the effort, studying the human response to the signals and how exposure to such advanced concepts reshaped thought processes and cultural norms. Amid the excitement, caution persisted. Global councils debated the ethical implications of new discoveries. The possibility that the signals could alter reality itself demanded careful oversight. A single misstep could have consequences far beyond anything previously imagined. Yet the human desire to explore and understand was impossible to contain. Risk and curiosity danced together, inseparable in the pursuit of cosmic truth. Riko Tanaka, now a recognized leader in the research community, had developed a method for modeling the signals using high-dimensional matrices. Her algorithms allowed for visualization of multi-layered sequences, revealing connections that were invisible to conventional analysis. Through these models, the team noticed a recurring motif structure that resembled a bridge, a pathway leading from one framework of knowledge to another. As though the sender had anticipated humanity's cognitive limitations and created scaffolding for learning, the implications were staggering. The signals were not merely information, they were pedagogy. They guided thought, prompted discovery, and shaped comprehension. Humanity was being taught, nudged toward an understanding that spanned not just physics or mathematics, but a holistic comprehension of the universe's architecture. Meanwhile, the public engagement was extraordinary. Educational programs based on decoded patterns were introduced worldwide. Students were learning advanced mathematics and physics decades ahead of normal curriculum, inspired by real-time cosmic discovery. Artists began incorporating the signals into visual and musical works, creating performances that echoed alien rhythms and structures. Even ordinary citizens felt connected, as though the universe itself had extended a hand and invited them to participate. One evening, Jot Tortes convened a global conference via holographic transmission. The room, virtual and physical combined, was filled with minds from every continent. Representatives from space agencies, universities, and private research firms presented their findings. It was a convergence of intellects, an unprecedented collaboration that transcended borders, politics, and even disciplines. In the conference, discussions turned to the philosophical. Could humanity ever truly understand the sender? Some argued that the signals represented a form of consciousness beyond human perception, a mind that thought in dimensions and temescals incomprehensible to humans. Others believed the pulses were designed to be understood if approached with patience and correct methodology. Debate was intense, but consensus emerged. The journey itself was as important as the destination. As research progressed, subtle anomalies in the signals began to appear. Patterns shifted, sometimes almost imperceptibly, as though reacting to the methods used to decode them. It was a feedback loop. Humanity interpreted the signals, and the signals responded, introducing new layers of complexity. This dynamic interaction suggested not only intelligence, but awareness and active engagement with the observers themselves. Global technological advancements accelerated. Quantum computing, once a niche field, became the foundation of new research infrastructure. Laboratories designed to interface directly with the signals were constructed in orbit, beneath oceans, and in remote deserts. The goal was no longer merely understanding, it was creating systems that could adapt and interact with the signals in real time. Despite these advancements, uncertainty lingered. The more humanity understood, the more questions emerged. The signals hinted at phenomena that challenged the very laws of physics as understood on Earth. Non-local interactions, temporal anomalies, and structures that seemed to exist across multiple dimensions simultaneously. Scientists debated whether these effects were practical, theoretical, or even safe to pursue. Amid these debates, a young prodigy named Amina Hassan discovered a connection between the signal sequences and human cognition. Her research suggested that exposure to the signals enhanced abstract reasoning, pattern recognition, and even emotional perception. It was as if the communication was tailored not only to transmit knowledge, but to elevate the consciousness of those who engaged with it. This raised profound ethical and philosophical questions. Were humans being altered in ways they could not fully comprehend? Yet the allure was irresistible. Governments and private organizations invested billions into exploration and experimentation. New instruments were designed to detect subtler features of the pulses, to capture data that could previously not be measured. Every breakthrough revealed layers previously unseen, like peeling back infinite petals of understanding, each more intricate than the last. Doctors often reflected on the nature of the endeavor. The universe, she realized, had extended an invitation, not merely to observe, but to participate. It was a challenge, a test, and an education rolled into one, a cosmic curriculum for a species on the verge of its greatest leap. The threshold of understanding lay before humanity, vast and uncharted, promising both revelation and peril. And yet, as the world pursued this unprecedented knowledge, a sense of unity emerged. Nations collaborated, communities learned, and individuals found purpose in the pursuit of comprehension. For the first time, the stars accessible, not as distant points of light, but as beacons guiding human thought and endeavor. Humanity had crossed the first threshold, and beyond it, the universe awaited with mysteries yet untold. The first half of Chapter 5 concludes with the recognition that humanity's journey had only begun. The signals were no longer anomalies, they were catalysts. Every decoded sequence, every mathematical insight, every artistic interpretation pushed the species closer to a new epoch. Yet the greatest challenges, the deepest mysteries, lay ahead, hidden within the folds of space, time, and understanding itself. The next morning, the orbital station hummed with renewed activity. Teams prepared to initiate the first fully autonomous interaction with the signals using adaptive quantum arrays. These arrays were designed to respond dynamically, adjusting their parameters based on feedback from the pulses themselves. It was an experiment that combined physics, computation, and intuition, a fusion of human ingenuity with alien guidance. Doctors walked among the arrays, her eyes scanning the streams of data cascading across the translucent displays. Each signal carried immense complexity, yet within the chaos was an unmistakable order. Patterns repeated, diverged, and evolved, like the choreography of a cosmic symphony. Every day brought a new revelation, a new layer of understanding, and with it, a humbling awareness of the vastness of the unknown. Amina Hassan joined her, carrying a tablet filled with freshly analyzed cognitive metrics. "The results are remarkable," she said, voice tinged with awe. "Participants exposed to the new interactive protocols are showing accelerated problem-solving skills and enhanced spatial reasoning. It's as if the signals are teaching us not just information, but the act of thinking itself." Dr. Cortez nodded. "This is why we must be careful," she replied. "Enhancing cognition is one thing, fundamentally altering perception is another. We're reading on territory that no human has ever mapped." The research station's communications terminal chimed. A new pulse had been detected, one unlike any before. It was denser, richer in frequency, with embedded harmonics that seemed to resonate with both matter and consciousness. The team gathered around the screens, their faces illuminated by the shifting patterns of the signal. There was an almost palpable sense of anticipation. This could be a breakthrough or a warning. As the arrays processed the pulse, an image began to form, a lattice of light that stretched across multiple dimensions. It was not merely visual, it had texture, weight, and rhythm, as though it existed simultaneously as information, energy, and perception. Researchers realized that the pulse was a map, but not of stars or planets. This map represented connections, pathways, and possibilities within the very fabric of reality. "This is beyond anything we imagined," whispered one scientist. The words felt inadequate. The experience transcended language. The lattice seemed alive, responsive to observation, adapting in real-time to the patterns of attention and inquiry from the team. It was a living pedagogy, not just transmitting knowledge, but shaping understanding at a fundamental level. Global reactions were swift. News outlets described the discovery as a cosmic awakening. The public responded with a mixture of fascination, reverence, and fear. Debates flourished in forums and academic journals alike. Should humanity attempt to interface fully with the lattice, or was restraint the wiser path, avoiding potential consequences that could be catastrophic? Doctors convened a council of the world's leading thinkers, ethicists, and scientists. Holograms and live transmissions linked continents, forming a tapestry of collaboration unparalleled in history. Every breakthrough carries risk, she said, addressing the assembly. To refuse engagement is to deny the species its destiny. The universe is offering a hand. We must decide whether to grasp it fully, cautiously, or not at all. Over the following weeks, experimental protocols were established. Simulated environments were created to safely interact with the lattice, enabling incremental exploration. Scientists developed specialized suits and neural interfaces that allowed direct cognitive alignment with the pulses. Human thought became both instrument and observer, a participant in the unfolding cosmic dialogue. Riko Tanaka and Mamini Hisson led the first successful cognitive integration trial. As their minds aligned with the lattice, they experienced perception beyond ordinary senses. Time and space no longer constrained understanding. They could sense potentialities, causality threads, and interconnections across distant regions of the universe. The experience was euphoric, terrifying and humbling all at once. "Do you feel it?" whispered Riko. Amina nodded. "It's as if every question we've ever asked has an answer waiting somewhere beyond perception. We can see the scaffolding of reality, the hidden rules guiding existence." Back on Earth, the world watched these trials with a mixture of awe and apprehension. Educational systems incorporated the insights into curricula, philosophical debates flourished, and even art transformed to reflect multi-dimensional perceptions. New forms of music, painting, and literature emerged, inspired by the signal structure and rhythm. Human creativity was expanding, reaching heights that had been unimaginable only months before. Yet, amidst the exhilaration, subtle anomalies persisted. Some researchers reported fleeting visions of entities or presences that seemed neither alive nor artificial. These were glimpses beyond normal cognition, hints that the lattice might not be purely informational, but semi-sentient, an intelligence that observed as much as it was observed. Questions